In this video, I'll show you how to solve the ALEKS problem called writing the electron configuration of a neutral atom with a filled D subshell. So I'm going to show you how to do this by reading the electron configuration off of a periodic table. I've got this blank periodic table. It's got this element highlighted. I want you to ignore that. I just copied this blank periodic table from a different ALEKS problem that had something to do with this particular element. So we're going to use this. Ignore the highlighting. When you are using the periodic table to read the electron configuration, what you're basically doing is starting in the upper left-hand corner at the element hydrogen, and you are reading the periodic table from left to right, top to bottom, until you get to the element that you're being asked to come up with the electron configuration for. For me, it's antimony Sb. The elements that I highlighted in pink here, these are the elements that correspond to the filling of the S block or the S shells. The numbers of the horizontal rows pertain to the principal quantum number. So in this area, this is where we are filling the 1s subshell. In this area, this is where we are filling the 4s subshell. These elements here would be the 6s. You get the idea. Next, over on the periodic table, so all of these are transition metals. Right here, these are the elements that correspond to the filling of the D shells, the D subshells. I'll come back to that in a second. And then on the very right-hand side, these elements are mostly the nonmetals. These are the elements that correspond to the filling of the p orbitals. Here, so these are the p orbitals, and again, this the number pertains or corresponds to the group number or the horizontal row. So these would all be the 2p elements. These ones right here would be corresponding to the filling of the 4p blocks, etc. For the d elements, the numbers are one row behind. So even though this is in row number 4, it actually pertains to the filling of the 3d orbitals. Even though this is row number 7, it pertains to the filling of 6d. So again, these are all one number behind. These would be the 5d. And then I'm not sure if it's going to come up or not on this problem, but there are two more rows on the periodic table down here. And these elements are the ones that pertain to the filling of the f orbitals, if it happens to come up on one of your problems. So these would all be the f's, and these are located in this spot on the periodic table, and they are also one behind from the d's. So this row is actually located in this area of the periodic table, and instead of being 5, it is 4f, and then this one is 5f. Okay, so this is kind of our shortcut for filling in to read the electron configuration based on an element's location. And notice that I didn't highlight helium. I did highlight the extra space. That is because when we're using this trick, we like to think of helium as being located at the top of column 2A instead of at the top of 8A. And what we need to do is use a regular periodic table to locate our element. For me, it is antimony. Antimony is located in that spot right there. I've got to find it on this particular periodic table. It looks like it is in column 5A, and it is in row number 5. So it's in that particular spot, which I'm going to kind of highlight, black it out, and yeah, that's in the right spot. So we're just going to, like I said, we're going to start at hydrogen, and we're just going to read across the periodic table from left to right and from top to bottom. Now, if you're familiar with doing the electron configurations, one of the things that I have noticed about this problem is that it looks like you can't use the noble gas abbreviation. You've got to write the full electron configuration out, which is a little bit tedious. Starting at the very top, this is the area that corresponds to 1s. So this would correspond to the filling of the 1s orbital with 2 electrons, 1s1 and then 1s2. I'm going to write that down, make sure I give myself lots of space because I think this is going to be big. And I'm just going to mark these off so I can keep track of what I've done. And then from there, we go to the next spot, which is here. This corresponds to the filling of the 2s orbital. There's 2 spots there, so that would be 2s2. And then we move across. Now we're in this area. This area corresponds to the filling of the 2p orbital, and we have 1, 2, 3, 4, 5, 6, 2p6, From there, we continue. We have 3s, 1, 2, and then 3p, 1, 2, 3, 4, 5, 6. 3s2, 3p6. Mark all of those off. And then we move on. This is our next area. We have 4s2, 4s2. And then we go into this area. This is the D's, and remember they are one number behind. So this is going to be 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then over here, we are in the P's, and we're back at 4. This is 4P. 1, 2, 3, 4, 5, 6, 4P6. Moving on to the next row, we have 5S, 1, 2. We are in the D's, one number behind, so this is 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4D10. And then finally, we are in the area where antimony is located. We're back to the 5. We're in the P, 1, 2, 3. 5p3. So again, no noble gas abbreviation allowed as far as I can tell. Also, in some ALEKS problems want you to order the electron configuration in order of increasing principal quantum number. But this problem doesn't appear to want you to do that. So it wants you to write, which is nice. It wants you to write the electron configuration exactly the way that you would read it off of the periodic table, exactly the way that I just did it.